So you're making, is this your bronze alloy?
Yeah, well, gunmetal, I guess, because it's copper, tin, and zinc.
You're just cold working it?
Yeah.
All right, now why are you striking it with the pointy end? Does that stretch it in one direction more?
Yeah, I'm trying to get more width out of it. Really need to fasten this to something so it quits jumping around.
Yep. Hey, welcome back to Engineer's Workshop. Got a little bit of this, a little bit of that to show you in this video. Been doing some work here in the big building, and one of the things we've done is, if you remember, I had a big stack of maple slabs right here in front of the K&T. That has now moved down out of the way of the overhead hoist. We had to move these one at a time and shift them and sticker them up good so that they would continue drying. So that frees up this area right here, and we can now move things around in the shop a little bit easier. So a little of this, little of that. Got a new machine I want to show you that my son picked up. No big deal, but it's kind of neat. It's very old. Couple of small projects that I had to get out of the way, both on the K&T and on the lathe. And I started playing with the Dumore Toolpost Grinder. So let me show you all that in no particular order, and we'll see how far we get today.
Prepared to lower it down. Weight, obviously.
It probably is not bad. I think it's some oil.
It's bad enough that we gotta redo them. You can hear it audibly jiggling around.
Does it have shimmable thingies?
Probably. There's a lot of grime.
We have a new machine in the shop. This is a Crescent 20-inch bandsaw. My son picked this up. It was pretty cheap. I think it's like 125 bucks. Babbitt bearing. There is some play in the bearing shells, and these do not appear to be, two-piece bearing shells where you can adjust the shims. So these are poured and then bored, which, I don't know, I mean, it's probably not going to be too big of a deal to remake these, because they're small enough they can be put in the lathe and just bored in place. Actually, the lower mandrel has caps and two-piece bearings. The upper is a one-piece. So there's a tilt feature, and there's a pivot on this upper wheel to get the axis of this wheel in line with the lower wheel. No motor on this. I've seen this basic model in catalogs and brochures on Keith's site as old as 1898 in foot pedal, shaft driven, like belt driven. And I don't know, there's like 3 variants. The 1898 price was $40, which was kind of cool. So this is going to take a little bit of refurbishing, new tires, thrust bearing for the guide. But this is a nice size to run, 1/4 inch to 1/2 inch blades. I have a 38-inch American bandsaw. I got videos on that if you want to check back in the archives of the channel. And we also have a Mershon 54-inch resaw, which is more of a sawmill piece of equipment that my son has to refurbish. But check that out. Those are all pretty cool to take a look at. But nice little addition to the shop. Decided to play with the tool and cutter grinder a bit, at least get it fitted up and on center with the lathe here. So I'm going to remove the tool post and see what's involved with switching over to running the tool post grinder. This is a McMaster nut with a integral bearing and a thrust shoulder. Get this a little bit closer. So this can really be tightened up nicely. First thing that has to be done is the thickness of this is a bit high to fit inside the T-slot, not by much. So I'm probably going to put this in the lathe, face it, and then that way it'll fit in here. And it's too narrow this way, but it will grab, and it's too long that way. So I would have to take, I don't know, 1/4 inch off the length total in order to fit it like this. So let's go ahead and make that modification. So in order for this to fit, we have to come down to 354. And what is this? It's about it's 3/8, 375, 376. So 354, and the width has to be 1970, about 1970. Need to remove a total of 20 thousandths, so this is the first 10 thousandths. This cut should do it. That should fit. Just kind of doing a rough check to see how well centered we are. 1.368, 1.365. So the stud is reasonably centered between those two edges, so we can take half the amount off of off of each one. And we've got to go from, let's say 2.260. We got to take 145 thousandths off of each edge. So 145 off of each edge like that. Over at the K&T, and I've got the piece centered up in the vise. I'm just going to go and take this cut at one time. We'll bring the quill down, bring the knee up, bring the quill down until we touch, and then we'll dial in the 145 thousandths right on the feed of the quill. Sometimes what I like to do is drop the knee. Actually, I can drop the knee 2 thousandths because I've got the quill. There, quill's on 0 right now. So let's dial in the 145 and we'll lock it, and we'll see how we do on the table feed that I have. Kind of keep an eye on this piece here. That's a little fast. Still a little fast. Need to make sure this didn't pick itself up. Okay, I'm zeroed on the edge there. We got to come down 145. I don't think you can ask for a much better fit. Just from the quick glance, it looks to be reasonably well centered. It's going to have to come up just a bit. Compare it with the tail stock for now. It's actually real close. I have a wood wedge under here. I'm just driving in until I get the axis of the spindle coincident with the axis of the shank here. I think they're both 3/8, so that makes it easy. Before I get too far along here, I want to set my compound at 6 degrees. And the reason I want to do that is because 6 degrees from parallel with the axis of the lathe will give me a 10-to-1 mechanical advantage on the movement of the compound, let's just say relative in and out to the work, so that very small movements of the compound, like if I move the compound 1/1000th of an inch, that's actually moving the tool, the grinding wheel, in a 1/10 of an inch, a 10,000th of an inch. So it gives me a 10-to-1, mechanical advantage on the movement of the compound, 10-to-1 in the favor of a smaller movement. Just eyeballing the axis of the spindle parallel to the bed of the lathe for now. I have a belt on order, but I'm going to see if I can make up a temporary belt out of these. I think they're copier belts, and I'm just gonna crazy glue, cleave them square and then crazy glue them together. I've seen this done with O-rings, and it's kind of amazing how much tension they will take. I suspect that these two pulleys are probably the smallest ones that will be used. So if I make sure that the motor is out almost to the end of its travel, then I'll make a belt that will work with the bigger pulleys. Let's see if we can hear how this thing sounds. It's a high RPM motor. It smoothed out when the RPM came up. Now, let's go see if we can make a belt. The only real trick to this is clean square edges and intimate contact between the two surfaces once they're glued. So usually this type of razor works best. Wax paper would be better for this, but I think this will do in a pinch. I'll let that set for a few minutes, and then we'll go try it out. This belt material would be absolutely ideal if this works, because each belt that I have has enough length for two, to make two belts out of. So I haven't tried this. We'll see if it can take the static tension of the motor here. And we're going to have to do something about this guard support. Looks like the spindle needs to move this way a bit. I'm just going to take this out for now. Don't know what clamps the spindle in place. It can't be it, just these two screws. That's about where it needs to be. Actually, no, that doesn't lock it. All right, if it survives startup, it should survive. So much for that. Well, I'm going to have to come up with a way to get a cleaner cut. Maybe I'm going to have to build a fixture for it. But I think that's a good length. So we'll try again. So I got a factory belt from Dumore for this, and it is a Mechadyne T150 19-inch belt. Unfortunately, with the large set of pulleys here, there's different ratios you put on here depending on what speeds you want. And the slowest speed for the biggest grinding wheels uses the number 4 and the number 1. And this is not long enough to work with that combination. So I'm not sure 100% that I have the right belt, but let me show you the grinding wheels I have and what I'm going to do. I bought two grinding wheels. I bought a coarse grit 4-inch by 1/2 inch. And even though it's a coarse grit, you can still do some pretty nice finish work on that. That has a max RPM of 5,800. I've got a 3 by 3/8, and this is a finer grit. The max RPM on that is 7,600. But in order to have a belt combination that works, I'm going to need to go with a number 2 and a number 3, and I've tried that. And that is only a good speed for this 2-inch grinding wheel. And this, it looks like the grit is somewhere between these two. This thing is soaked with oil. I'm gonna give it a try. I'm gonna be careful doing it, but that's the only one that will work with the belt combination that I can actually work with this. I've got my little diamond dresser from the Cincinnati number 2 tool and cutter grinder set up just below center, clamped onto the back of the lathe bed. I don't have this square to travel because of the small diameter of this. It's not going to clear the backside of the wheel guard, so I just cocked the grinder inboard. I'm going to dress just a small flat on the corner of this wheel. This is just a kind of a practice wheel anyway. And then I'm going to give it a try on the OD of the locking knob that we made and see if we can just get that to a uniform looking finish. So let's fire this up, give it a second to warm up, and then we'll dress it down. You can see by the light that I've got a band about half the width of the wheel, which is all I need just to do the OD of this locking knob here. I've got my lathe on very low speed. I've got the feed up to a high rate of feed, so I get a fairly fast traverse, but you know, we'll see what we get. And I'm going to run the engage lathe in reverse here. Let me change my feed direction. It's a beautiful finish where it has touched. You can see where it has yet to clean up. Just advancing it about 1/1000th at a time. One more pass for good measure. That is really cool. Just a basically perfectly uniform finish. Got a little bit of warmth to it. I'm gonna spray it down with WD-40 so it doesn't rust here in the meantime. Actually, I'll use my CRC cleaner there. Man, that's pretty neat. As a real quick job, I want to open up one of my tool holders to accept a 3/4 inch shank tool. It's just a chamfering tool. So we're not talking about something that I'm going to be taking horrendously heavy cuts on. And the existing groove here is about 645. So 645, got to go up to 750 and change to hold that shank. We'll touch off the bottom, touch off the side here, zero it, and then proceed through with the cut. Hundred and 10 thousandths. Got a 2.5 inches per minute table feed. That'll do what I need it to do. Well, I reconditioned my 3/4 inch Jacobs ball bearing Super Chuck. Pressed off the sleeve. I found an old video from Steve Summers on how to rebuild these things, so I followed that. I don't think that he mentioned that it's better to have 3 hands when you're doing it, because once you get this split inner race off here and you're holding that back together and you're loading the balls back in, I lost tension on it at one point and the balls fell out. And I was already maybe, I don't know, 1 or 2 short when I took it apart, and ended up not being able to find a couple of them. So I had to order a pack from McMaster. They're 7/32, but man, this is a nice, smooth acting vise. So I have a brand new, just a Shars, number 3 Morse to number 4 Jacobs taper shank here. I'm going to take out my old live center, and we're going to pop this guy in here. Make sure I'm between the tabs. Seat him. Then the Jacobs chuck has an oiling screw. I'm going to orient that at the top. Get my jaws retracted. There's one massive chuck compared to this. That's a 1/2 inch chuck, by the way. Sweet. I do have a couple of drills. I got a number of straight shank drills. For some reason, I don't even know why I have so many at 11/16. So we'll be able to, use this. I do have starting to have a nice selection of, Morse taper shank drills that I can load directly in here, but I think I'm just going to keep this in here for now, for using it for centers and any straight shank drills up to that 11/16 that I have. So love having this on the lathe. Can't resist trying it out, so let's put a relatively small 7/16 drill in here. And this is a nice short one. No problem at all. Well, I hope you enjoyed that. A little bit of a shop update. Making progress here on getting the shop cleaned up. Got some work done on the K&T, got some work done on the lathe, played with the tool and cutter grinder a little bit. So back at it again next week with more projects. I keep saying I got to get back working on this radial arm saw casting to clean up the weld, and I finally got a piece of tooling that might help me clean up that bore, so we'll get into that next time. So thanks again for watching and subscribing. It helps when you like and share the videos with the algorithm, so please do that and help me grow the channel. Welcome again to all the new viewers. And once again, from Engineers Workshop, as always, until next time, stay safe.